And let's do probability of, I'm just going to say X, or let's just say probability of the 86 of the, I'm just going to say Z being greater than, no, the probability. I'm thinking 2 or 3 different things right now. Probability of X being greater than or equal to 2.2. And probability of X being less than or equal to negative 0.6. And then P, probability of X being between 1.2 and 0.5. All right, so there's your 3 handy dandy probabilities. So what I want you to do, we're going to try to draw them on 1. I don't know if I'll be able to draw it on 1, but here's our normal curve. And 0, 1, 2, 3, negative 1, negative 2, negative 3, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And we're going to do the 2.2. We're going to do that in pink. That pink is about shot. Let me get another pink. That one's going in the, I think that one's going in the, there's pink. So 2.2, oh, we picked up somebody. All right, Yates is with us. Good morning, Yates.
Good morning.
And she's going to talk to me. Well, will you be the one that guides me this morning, Miss Yates? Because Mr. Pacetti wasn't here Friday, and nobody else will talk to me this morning. So, were you here Friday? Okay, she left.
It keeps knocking me out of the call.
I don't know why.
I don't either.
It must be your, it must be you don't want to be in class this morning. I don't know why it's doing that, because I'm not getting any messages on my end. It might be your internet. Okay. Let me know if it keeps doing it, because I don't know if I can fix it or not. Okay. So there is the pink. So pink is 2.2, and they want to know greater than, so that would be this area right here. And then we're going to do, we'll do a definitive color between orange and pink. Let's do green. We'll do green is less than negative 0.6. Well, there's negative 0.5. So negative 0.6 would be right there. And then I want to the left. There we go. And then orange, we'll do right here. And that's going to be 0.5 to 1.2. May want to know that area right there. Now, I'm going to go ahead and I'm going to take my empirical rule, and I'm going to do the empirical rule in a purple, like a lavender. My empirical rule is going to give me, for this one, empirical rule. Notice I put an equal with a dot over it. That means somewhere abouts. And that's going to be, let's see, what is 2.35 plus 0.15? We know that's 2.5, right? So our pink is less than 2.5. So I'm going to say around 2.2 or 2.3. 2.2 or 2.3, which means 0.0220 or 0.0230. And that's coming from the empirical rule. And my empirical rule here for the green, let's see, that's 2.5, that's 13.5, that's 16, and then 34. Well, this is not half. Half would be right in there. Half would be 17. So I'm going to say it's around 15. What 15 and 16? 31. So I'm going to say around 31% or 0.3100. And then the empirical rule here for the orange, well, it's going to be kind of hard to do, but I know that 0.5, that's 17% here. And then this is 1.2, so that's like a quarter of 13. Half of 13 is 6, and that's 3. So 3, I'm going to say around 20%. Or 0.2000. So I just used my empirical rule to look up these average, I mean, not these averages, these percentages based on the empirical rule. Now, again, it's rough, but it'll tell you if you're in the right ballpark when you do your calculator work. Now, let's remember, let's put in red here. This arrowhead down here is called negative infinity. And this arrowhead up here is called positive infinity. But we can't use infinity in our calculations. So down here is going to be negative 9999. And this is going to be positive 9999. Now tell me, did I go over this with y'all, but it was in a hurry? Didn't we do something like this Friday? I think we did. Okay, thank you very much. Appreciate y'all's input. It's always nice to have input. So I'm going to hit second bars, binomial CDF. And for my pink, somebody tell me what my lower value for my pink is. Somebody tell me. What's that value right there?
2.2.
Thank you. So what is my parameters going to be for my pink? 2.2 on the left, and what? It's already there. Somebody read it out. Or it's right there.
9999.
9999. Now again, You can use 10,000. You can use 9,999. You can use 900 if you want to. It's up to you. And go to paste and enter. They got 0.0139, which is 1.39. I said it was going to be 2.2 or 2.3. So I'm a little bit off, okay? So the answer is 1.39% or 0.0139. That's the answer, 0.0139. That looks, that focus is a little bit off. That a little bit better. Yeah, that's good, Hubert. Thank you, class. All right, now, what is the lower limit on the green?
-0.6.
Not -0.6, lower limit. Which way do we read? Left or right? What's the left limit?
-9,999.
-9,999. So second bars, normal CDF, -9,999, and the right is -0.6. And we said it was going to be around 0.3100 by the empirical rule. 0.27, so we're a little bit off, but not far. 0.2743. And we'll do that in green. 0.2743. So that is this area. 0.2743. And now we're going to find the orange area. So second bars, normal CDF, 0.5 and 1.2. And we said it was going to be close to 0.2000. 0.1936 or 35, 0.1935. And that's how you do to the right, to the left, and in between. Now, what if they give you one like this? What is the z-score that corresponds with a probability of 5273. Now, before you were given a z-score, and you found the what? The probability. Okay. You were given, they said, find the probability of between 0.6 and 1.8. Okay. They gave you the z-scores. Here, we are given the probability, and we need to find the z-score. Okay. So this is two types of questions you might see. One, you might be given the z-score and you find the probability. Or two, you're given the probability and you need to find the z-score. I'm sorry. Okay, so here we are given a probability and we need to find the z-score. What do? Well, you go to second, vars, inverse norm. Write that down, inverse norm. And then you just type in the probability. 0.5273. Well, before I do it, I'm going to draw my handy dandy curve. And we're going to use the empirical rule and rough it in. Now, somebody tell me where 0.52 is near. Using the empirical rule. Well, let's write them down. 0.15, 2.35, 34. I'm sorry. 13.5, 34, 34, 13.5, 2.35, and 0.15. Where is 0.5 on the empirical rule? Okay, I'll ask it again. Where is 0.5 on the empirical rule, on this curve? Where is 0.5?
It's in the 34 quartile between 0 and 1.
Thank you, Miss Griffin. It's between the 34s, right? Just like a half a tank, just like on your fuel gauge on your car. Half a tank is straight up and down. So 50%, I'm going to take my blue marker, which I hardly ever use the blue marker. 50% is right there. So we know that 52%, because you can change this to 52.73 or 53%, you know, for eyeballing. Sorry. 53%. Well, we know that this right here is like 17%, because half the 34 is 17. So you're not going to be able to bust that down. Let's see, 3. We know that 3 will go into 15 5 times. So you could put 5 slithers. 1, 2,
okay.
3,
Yeah.
4. What are y'all laughing about? Come on, share.
My mom just got home from taking my sister to school.
Oh, well, tell her I said hello. All right. Glad she made it home safe. All right. So I just broke 17 up into 5. So that's 3. So here we go. there, right there, is that 3%. And it's rough, but, and I've just divided 1.5 into 5 segments. So I'm going to say it's going to be around 0.1, 0.10, my z-score. Now this is based on empirical rule. I'm thinking I'm going to be around 0.1. That's a point right there. I made it kind of too big. But I think my z-score is going to be around 0.1. And I just used the empirical rule to show me where the answer would probably be. And that's rough. So now I'm going to go back to my calculator. And I'm going to type in 0.5273. And hit paste. And let's see how close we are. 0.0685. So my answer is 0.0685. That's my, no, I'm sorry. 0.07, because we go to 2 decimal places on the z-score. So my z-score is equal to 0.07. Z is equal to 0.07. And I was pretty close. I said 0.1. So I was 0.03 off. Okay, so let's do another. I want to know the z-score. Give me the z-score that corresponds to 0.2377. Give me the z-score that corresponds to 0.2377. Now I want you to draw it first. Zero, 1, 2, 3. -1, -2, -3. 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. So let's just say, since we're doing the empirical rule, we're going to round this up to 24% or 24%. Now this is just for us because we're trying to see where the answer is before we calculate it. So where is 24%? Well, you know this is 2.5 and this is 13.5, so this is 16% right here. So this right here is 2.5%. And then this right here is 13.5. So to this point right here is 16%. Now we know that half of 34 is 17. So we know this is 17. We know that 17 divided by 3 is 5. So I'm going to put, again, 5 separations right here. 1, 2, 3, 4, 5. Okay, so that's 0.1, 0.2, 0.3, 0.4. All right, so what's added on to 6 to give 16 to give me 24? 8, right? By 8. So that'd be this first one, this second one, and maybe close to this third one. That's 6. Yeah, we'll just go ahead and fill in that third one too. We know this is 0.5. That's 0.6, 0.7. So I'm going to say it's right at negative 0.7. That's what I think. Because that would be 16 plus 9. 16 plus 9 is 25%. So I did it roughly at 25% and got negative 0.7. So let's see what the...
You have a work email.
Let's see what it says. Turn it on. There we go. Second bars, inverse norm. And we're going to do 0.2377. And paste. And what we think it's going to be around negative 0.7. Look at there. It's a miracle. And our answer is 0.71. Negative 0.71. And that is the very detailed calculated z-score. Negative 0.71. Now, if you understand everything I did, then you are good to go for 7.1 because you know how to do the empirical rule, you know how to use the empirical rule to estimate for the z-score, and you know how to do the empirical rule to estimate an area. That empirical rule is very important. Just curious, remind me, how many of you, raise your hands electronically, how many of you have had probability and statistics before? Leave your hands up. I want to see. Okay. Now, okay, put your hands down. 4 people, put your hands down. Now, of the 4, how many have done what we're doing right here? That's what I was thinking. I didn't think, let me guess, did y'all have it in high school?
Yeah, I did.
Okay. And you'd never seen this before?
Nope.
Yeah, I kind of think they go to an introductory level. I bet you've seen what we've done in Unit 1 and Unit 2, haven't you?
Yes.
Yeah, I kind of figure that's what they go up to. Okay. And of course, the 3 people that didn't raise their hand, they're totally lost, right? Come on, don't tell me you're lost. Okay, they're not going to talk to me. Mr. Pizzetti, you'll talk to me, won't you? You're not lost, are you?
Not completely.
Okay, good. Because the other 2, they're not going to talk to me. Miss Yates, you still with us? You're not getting kicked out again, are you?
I did, but I got back on.
Miss Yates, I kind of feel like you're in bed and half asleep.
Why?
At least you're honest, right? Okay, so let's go to the last part of 7, which is what do you do when the numbers are different? And this is the last type question you'll see in chapter 7. Find the probability of, we'll do an IQ test, of an IQ test being greater than 120, with the mean being 100 and the standard deviation equal to 20. This time we're not going to use z-scores. We've got to do 100, 120, 140, 160, 80, 60, and 40. Now we can still do the empirical rule, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Now let's go ahead and do our estimate. We want to know greater than 120. So 120 is right here. And remember, this end up here is 9999. This down here is negative 9999. Now, of course, you don't need to worry about this because we're up here, so you got to worry about 9999. But we don't have a z-score right here. We have a test score. And I'm going to put this, you need to put this right here. X is equal to 120. Now, that's important that you remember that, because there's going to be some times that you've got to find X. And I'm going to give you the formula for that here in just a second. Sometimes you have to find X. All right, so I say it's 16%. By the empirical rule, I say it's 16% or 0.1600 by adding up these three. Okay, but we've got to change 120 into a z-score. Z-score is equal to x minus mu over standard deviation. Now, do y'all want the good news or the bad news? And nobody says a word. The bad news is you got to do this calculation to change that into a z-score. The good news is sometimes, depending on what kind of calculator you have, the calculator will do it for you. So for these next few problems, I'm going to do both. Now, I'll show you in just a minute how to do it on the calculator. So the z-score is equal to 120 minus 100 over 20. And that's equal to 20 over 20. So that's equal to 1. So this z-score is equal to 1. Now you could tell that by the way it fell out, but sometimes it's not going to fall on the even numbers, okay? It's not going to fall on the whole numbers. Usually there's a decimal in there, like 1.6 or 1.2 or negative 0.56. So you're not always going to fall on a whole number. Okay, now, if you have an older calculator, the older calculator, you will type in from 1 to 9999. Okay, so the older calculator, you're going to type in normal CDF, and you're going to type in from 1 to 9999. If you have a newer calculator, you can change the mean and the standard deviation. So this is how you can tell. Second, vars, normal CDF, and type in your lower limit of 120 and your upper limit of 9999. And if you can change the mean and the standard deviation, then you're good to go. And I'm going to go ahead and find the answer because I'm going to show you something. I got 1.1587, and I said around 16%. So 0.1587. That's your answer. Now let's go back if you've got an older calculator. If you've got an older calculator, second, vars, normal CDF, and I'm going to type in 1 to 9999, and then I can't change 0 and 1 because my older calculator won't do that, and hit enter, and you get the same thing. So please let me know if you don't know if you have an older calculator or not. If you have an older calculator, you're not going to be able to change. Oops. You're not going to be able to change that 0 and 1. On a newer calculator, you can change it. So if you have an older calculator, you're going to have to change your test score into a z-score. And then do this. If you have a newer calculator, you don't have to do either one of these. Hopefully everybody understands that. Now I'm going to show you the last thing in chapter 7, and that'll leave us with Wednesday and Friday to go over material and review. Here is the last question on 7.2. 7.2, and it's going to say, given mu is equal to 100 and the standard deviation is equal to 20, find the test score that represents .7600 or 76% or P sub 76. It's written there's 3 or 4 different type questions, and one of them will say 0.76, and then the other one will say 76 percentile, or it will say 76 percentile like this. So you might see different ways of, but it's all the same thing. Draw a picture. So 100, 120, 140, 160, 80, 60, 40. And you do everything like you've been doing. 0.76, you know that this is 0.5, you know that this is 0.84. So 0.76 is going to fall somewhere in here. I don't know where. I'm not going to worry about it because we're kind of cut for time right now. So I want to estimate it. You can estimate it if you want to, but it's the 0.76 is between 50% and 84% by the empirical rule. So it's in here somewhere. And you know the score is going to be between 100 and 120, but how do you get it? Well, the first thing you got to get is the z-score. You got to get the z-score first. So you got to do inverse norm. Now again, if your calculator is a new calculator, you can change second vars, inverse norm. You can change your mu and your standard deviation, and you can type in 120, and it will give you the z-score. I mean, it will not only give you the z-score, it will give you the test score. So I'm not going to do that right now. I'm going to show you how to do this the old way first. Oh, that's not right. Hold on a second. Sometimes this happens. When this happens, there we go. Clear. There we go. Now, second vars, inverse norm. There we go. Area is 0.7600. And my z-score is, enter, 0.771. 0.71 is our new z-score. Now here is the formula that you need to use in case you have an old calculator. X is equal to Oz plus mu. And we started a little bit late, so I'm gonna go over just a couple of minutes. Okay, so that's going to be X is equal to 20 times 0.71 plus 100. Now somebody I'll do it because y'all won't talk to me. So 20 times 0.71 plus 100. And that is our test score, 114.2. 114.2 is the score that represents the 76th percentile. Now, if you have a new calculator, sit second vars, inverse norm, type in 0.7 and change this to 100 and change this to 20, and the calculator will do it for you. 114.13. Okay, it's a little bit off, but I'll take both answers. Okay. And that's it. That's 7.1 and 7.2. So I would highly suggest that those of you that don't talk to me and don't answer questions, I would highly suggest that you go back and watch the video today and rewind it a couple of times to make sure you understand 7.1 and 7.2. And then we'll go over homework questions and review Wednesday or Friday, because if nobody sends me questions Wednesday, then I'll go into, and I didn't check the homework questions this morning, so y'all may have sent me some. But if I don't receive any homework questions Wednesday, then I'll just move on into the review and pull the test up. Okay, let me shut this down and do the roll, and then y'all can skedaddle.